Hi. So I'm sorry. In a previous video, I mentioned that I was going to do both ion and an isotopes, but I thought it was going to be too long, so I'm cutting into two. And now in this video, I'm going to talk about isotopes. In the previous video, I mentioned about ions. Let's see. Let me just start with again sharing a slide. It would be better this time. Before that, okay. So ions have a different. Ion means it has either deficiency or excess numbers of what? Electrons, right? So the number of protons do not change. Means that when the atom becomes ionized, it's still the same element. It's just either it's electrically charged. So that's what it means by ion. Isotopes is the similar idea. Now isotopes have same number of protons, same number of electrons, but different number of neutrons. And also, whenever we hear, you might think that, oh, isotopes means scary. It could be radioactive. It's not necessarily the case. Definition of isotopes is not radioactive decay. Definition of isotopes is different number of neutrons. That's what it means by isotopes. So let me just go and share the screen here. Start from current slide. So here I have a definition of ion. Positively charged ion means deficiency of electrons, and the negatively charged ion means excess of electrons. And isotopes means that it's still the same element, but it has the different number of neutrons. So here, almost on the left here, we have a hydrogen model. Hydrogen has a 1 proton and a 1 electrons. 1 proton, 1 electrons. That's the typical hydrogen. However, some hydrogen do have 1 proton and a 1 neutron and a 1 electron. Or some other hydrogen have 1 proton, 2 neutrons, and a 1 electron. So here. Right? So it's just a heavier atom, heavier hydrogen atom. Because if you move from 1 proton, 1 electron hydrogen, compared to the 1 proton, 1 neutron, and electron, what is the difference of the two? Is it electrically charged? No, it still has the same amount of proton and same number of electrons. So it's both of them electrically neutral. Is an element change moving from 1 proton, 1 electron to 1 proton, 1 neutron, and 1 electron? No. Either way, the number of protons stays the same. So it's exactly the same element. It's still hydrogen. Hydrogen, still 1 proton, 1 electrons, hydrogen. 1 proton, 1 neutron, 1 electrons, hydrogen. 1 proton, 2 neutrons, 1 electron, still hydrogen. They're all hydrogen atom, except they have a different number of neutrons, and therefore it becomes heavier, right? Remember, the proton and neutrons is heavier than the electrons. So having an extra number of neutron makes the atom significantly heavier. So the isotopes means that number of protons is same as the number of electrons. It's just that different numbers of neutrons. So therefore, it's still the same element. And therefore, because it's the same element, it's just the same atom, it's just heavier. So it behaves identical behavior. It has the same character. But how you can tell if it's isotopes or not is by looking at their mass. because having that extra neutron makes the atom with the extra neutrons heavier. So let's say here, example, iron isotopes with 26 protons contain 30 neutrons, right? So that means that mass number of that iron is 56. But if you have a 29 neutrons, then it becomes the mass number to be 55. If you have a 31 neutrons and 26 protons, it's still iron, but mass number will be 57. Not this one yet. So let's go back. Oops. Let's go back to the, not this slide. I want to go back to periodic table. Maybe I should go back to the, it's okay. So let's look at the hydrogen. Can you find the hydrogen? It's pretty easy, right? Most left on the top left corner is the hydrogen, atomic number 1. So most of the hydrogen have 1 proton and 1 electrons. But when you see, it says H, that's the element, hydrogen, and it says hydrogen. And then on the top of H, it has that 1. It says 1, and that's the atomic number. But you also notice that at the end, bottom, under hydrogen, it says 1.0079. You see that? That's actually the atomic mass, 1.0079. But can you have a 1.0079 atom? No, atom is just a quantized, right? It's discrete number. You're not going to have a 2.5 U. You're not going to have a 2.5 human. You'll only have 1 person, 2 people, 3 people. You're not going to have a 3.2 people. So same thing, hydrogen, you can't have a 1.0079 hydrogen. So what does it mean for this 1.0079 that I said it's a mass, right? What it means is that it's the average. So most of the hydrogen have a 1 proton and 1 electrons. However, let me see, about 0.0015% of hydrogen, 0.015%, not 0.015% of the hydrogen are isotopes. So that means that you find 15 hydrogen, you find among the 10,000 atoms. No, I'm wrong. Among the 100,000 atoms, 100,000 hydrogen atoms, you're going to find about 15 hydrogens are isotopes that has more neutrons than the others. It could be 1 more neutrons or it could be 2 more neutrons. So when you take the average of the natural abundance of a hydrogen, then you're not going to have an atomic mass 1. You're going to have a more, so 1.0079. So that's what it means. And 15 hydrogen in 100,000 hydrogen atom, that's actually quite a bit. That happens in nature. Remember how many atoms you can find in a gram of water? 10 to the 23 atoms. So when you see the 10 to the 23 atoms in a gram of water, the 0.015% of the hydrogens are heavier than the other hydrogen. So you're going to find quite a bit of hydrogen that's heavier, and they're not, so just drinking a glass of water, you might have some isotopes, hydrogen, but are they dangerous? Can I get afraid of drinking a radioactive water? No, right? It's not necessary that they're radioactive. You see so many of them in natural, abundant of them in the nature. So they're not radioactive. They're stable. So isotopes can be stable. However, or some isotopes are radioactive. That's why we think about, like, what was it? The famous one is a uranium, right? Some carbons can be radioactive. So there's a radioactive carbon. But then there are other stable isotopes in carbon, like a carbon-12 and carbon-13 are stable, but carbon-14 is radioactive. So some isotopes are radioactive, some are not, some are stable, some are unstable. But not all the isotopes are unstable and radioactive. Just the definition of isotopes is, don't get confused, it's just a different number of neutrons. So still the same element, even though they decay to be a stable isotopes, stable element is still the same element. So let's see. I mentioned that the number underneath what it says the element. So let's see, carbon. Let's look at a carbon here. What's the atomic number of carbon? Atomic number of carbon is 6, right? How many numbers of proton and how many numbers of electrons? 6 and 6. 6 and 6. And then you look at the atomic mass. It says, what does it say? 12.011. Is that good? You see 12.011. So, but then this is the average. So that means that most of the carbon has 12 neutrons and protons. Okay? Some of the carbon may have more than 6 neutrons. Some of the carbons come with the 7 neutrons or 8 neutrons. That's why it's more than 12. So what it means by 12.011, we know that carbon has 6 protons, right? And the electrons doesn't weigh nearly as much as protons and neutrons. Remember, electron is so much lighter, 2,000 times, protons and neutrons are 2,000 times heavier than electrons. So having the extra neutrons gives a considerably difference in having just the number of electrons. So electrons doesn't weigh too much, and you don't need to worry about the number of electrons in the atomic mass too much in a change. So when he says 12.011, you're going to approximate, you're going to round it up to be, most of them is 12. And then we know that there are 6 protons, so 12 minus 6 is 6. So most of the carbon has 6 protons, 6 electrons, and 6 neutrons. 12 minus 6, that's the number of neutrons. And because it's more than 12 is atomic mass, so some of the carbon may have 7 neutrons. Let's look at nitrogen. What's the atomic number of nitrogen? 7. How many numbers proton and how many numbers of electrons you can find in nitrogen? 7 protons and 7 electrons, because the atomic number is 7. And when we look down, it says 14.007. How many numbers neutron in nitrogen? 7. No? Yeah, 7, right? So nitrogen have 14.007. So most of them is 14. So 14 minus 7. So 14 is the amount of nucleons, how many numbers of a particle in a nucleus, because they're the heavy ones. So then you have a 14.007 rounded up to 14 minus the atomic number 7, which means that 14 minus the number of protons is going to be the number of neutrons. So 14 minus 7 is 7. Let's look at oxygen. What's the atomic number of oxygen? 8. How many numbers of protons and how many numbers of electrons does oxygen have? 8 and 8, right? Atomic number 8, 8 numbers of protons, 8 numbers of electrons. It's not ionized, so same number of protons and electrons. Then you look down. Under oxygen, it says 15.999. So you're going to round up, because some of them maybe have a less neutrons. But most of them is 16. So 16 minus 8 numbers of proton is 8. So most of the oxygen have 8 neutrons, but maybe some oxygen has 7 neutrons because it's less than 16. So that's what it means by atomic mass. It's not a integer number, although the number of particles should be in an integer. But because some of the some of the atoms are isotopes, have some isotopes, so therefore when we take the average, it becomes a little more or less than typical element. So some oxygens probably have 8 protons and 8 neutrons and 8 electrons, but some of the oxygen may have 8 protons and 7 neutrons and 8 electrons. So I hope you can see how to find the isotopes, and then I'm going to probably ask you how many, to be able to find how many numbers of protons, how many numbers of electrons, and how many numbers of neutrons you can find in an element by looking at a periodic table. Okay, so let's see. So atomic number of the element matches the number of A, protons in nucleus of the atom. We're going to do this in the class. So that's it for the isotopes, and I will see you in the discussion.